Hello. Now we are going to look at construction 16. And construction 16 is to construct the circumcenter and thereby the circumcircle of a given triangle. So our first job is to know what type of center of a triangle we're talking about. There are several of them we're expected to know, and one of our big difficulties is how to remember which one is which. So our first job before the construction is to remember what we're talking about. So the circumcircle, there are two parts to this word. The circum part we've seen before in like the circumference of a circle means going all the way around the circle, or in history we might learn about circumnavigating the globe, means we sailed around or went around the globe. So the circum part of this name means to go around. So what we are looking for is a circle that goes exactly around the triangle. So it's going to be the circle that goes on the outside that goes around the triangle. So that is our circumcircle or our circumcenter. And again, it is important to labor that point when we're practicing these things. Which one are we talking about? There are several we need to know, and we need to know which one we're supposed to draw if we're asked for it. Now, there's a consequence to the fact that our circle goes exactly around our triangle, and that's that the vertexes, the corners of the triangle, are all going to be sitting on the circle, and that means the distance from any of our vertexes, any of our points A, B, and C, to the center of the circle is going to be the radius. And again, that can be relevant if they ask us more of a problem-solving type question. How does that, what type of center would we use if we wanted to have the same distance from a point out to the vertexes of our triangle? The way that we're going to do this is by constructing perpendicular bisectors of the sides. So all of the perpendicular bisectors of our line segments, of our sides of our triangle, will all meet in the same place. They'll all meet at the circumcenter. We'll talk about why, or look at why in a bit, but I am going to draw two of those lines here. I'm going to draw L1 and L2, and where they intersect is going to be the center. That's two of the lines. Again, any of the sides, the perpendicular bisectors of the sides, will work. If I take L1 as an example, I'm going to have L1 being the perpendicular bisector of AB, the line segment AB. Our square bracket means line segment. That means that we are going to go through the midpoint of AB. That's going to be the midpoint is going to be an element of the set L1, so it's going to go through the midpoint, and it is going to have a slope perpendicular to the slope of AB. So if we were constructing this algebraically, we would be able to find the midpoint and then get the perpendicular to AB, and that would describe the line L1. Now we're going to construct it by constructing the perpendicular bisector, which we already know how to do. If you haven't practiced doing a perpendicular bisector in a little while, do one separately before we start trying to do it in the middle of a more complicated construction like this. But I'm going to construct it now. So I'm going to take the perpendicular bisector of AB. I'm going to be looking for L1 as I've described it here. So I need to open up my compass to a little bit more than halfway between A and B. Open it up to about there. And I want to draw an arc above and below my line segment AB. And you can just draw a complete arc top and bottom. It can get quite messy, so what I'm going to do is actually just draw the arc roughly above where I think the middle of this line is, so that I have fewer lines moving around. Make sure the arcs are big enough to see them though. So the other thing you can see is my compass is having to move, and my arcs are going to be quite far outside of my triangle. So if you are drawing the triangle yourself, make sure it's in the middle of the page where you have lots of space on both sides. The lines where the circumcenter cross each other, or sorry, the lines crossing each other to give you the circumcenter can happen well outside of the triangle. So it is important that we have enough space to draw that. So make sure if you're drawing the circumcircle, you give yourself lots of space on the outside of your triangle. So in the middle of your page where you have lots of space. Now if I draw my arc here and then come around, do the same thing over here. and keep the compass in exactly the same size, and come around, draw our arc, come around, draw our arc, and where these arc crossing points occur, if I draw a line between them, I am going to get my line for my I'm going to get my line for L1. And again, extend these lines out past the arc. You don't know exactly where these lines are going to cross when you are working. So my line L1 is going to be my perpendicular bisector like that. And I can take my straight edge out of the way. So that's L1. And now I am going to draw in L2 of one of the other two sides. When I've drawn in L2, again the perpendicular bisector of AC, there's no significance to the fact that it went through AC. I could have just as easily gotten the perpendicular bisector of the line segment BC, and it would have gone through exactly the same point. So if you want to show that to yourself, do all three, but for the construction we only need to do two of them because they will necessarily all go through the same point. So I've now labeled in the intersection of L1 and L2, the perpendicular bisectors of our sides, and that must be the point D, which I've said is the center of my circumcircle. Well, if it's the center of the circumcircle, if I take my compass now and put it at the point, and I close my compass to any of the corners, and then draw a circle, it has to go around the triangle exactly. So that is the circle that goes around, that circumnavigates or goes around the triangle, hence the name. So the last thing to talk about, that's the construction done. The last thing to talk about is why this works. So this is based in geometry that we know. So it is important that we be able to try and piece together why this argument is working. And the easiest way to do this is to take the fact that we can see that in this setup, any of the sides of our triangles are now chords in the circle of our circumcircle. So if they're chords and we have perpendiculars going on, by drawing, I have their perpendiculars of chords, and we have the center involved. What do we know from geometry? What do we know from our work in circles already that would allow us to say that this is going to give us the center of our circumcircle? So it is important that we are using this opportunity when we're doing our drawing to think about how this would work algebraically in terms of the midpoint and the perpendicular that allow us to get L1 and L2. And why is the intersection of our perpendicular bisectors of our sides giving us the center of the circumcircle? How does that relate to what we know about chords and the perpendiculars to chords already in our geometry work? And that is what we need for now.